Hello Algebra 2 students. This video is to help you with the homework from Unit 4, Day 4, solving parabolas in vertex form. Although even though that's the title, this very first problem asks you to find the equation for a parabola, but the answer that they give you is in not vertex form, but in standard form here. So we're going to go ahead and use the distance formula instead of using the 1 over 4p formula. Here's what I mean. In this first problem, we are going to show that if we have a coordinate point xy, equidistant from this point 4, 3, if we're equidistant from a point, that makes that point our focus. I'm going to label that F. And it is also equidistant from a line, that line being at the equation y equals 5. That would be the directrix. So we're going to go ahead and find the equation of that parabola, and we are going to use the distance formula for standard form equation. A little bit longer process when we use the distance formula, but again it does give us the equation of our parabola in standard form as the one is in this problem. So very good idea to draw a sketch of the focus point and this directrix and get an idea whether or not the parabola is opening upwards or downwards, and whether or not, let me just get these points here, 4, 3 is the focus. So that's my point F at 4, 3. And the directrix I want to plot also, that's at y equals 5. So let's see, there's 3 high, 4 high, 5 high. I'm going to estimate here. This is y equals positive 5. Okay, so my vertex for this parabola is going to be right in between this focal point F and that directrix. So I'm going to go ahead and figure out where that is and place that point. Looks like from my focus to the directrix there's a distance of 2 units, so halfway would be 1 unit. There's my vertex there, and that would be at coordinate points. Let's see, I go over 4 on the x-axis and up 4. So this vertex, I'm going to write this over here, at the point x coordinate 4 and then up 4. That vertex is going to be a maximum because my parabola is going to kind of curve around that focal point. So I'm actually opening up downwards. So I would expect my leading coefficient to be negative. All right, I'm going to go ahead and write the distance now from my point xy. So I'm just going to pick a random point. I don't want to place it on any particular grid line. We're just going to call it x, y. And I'm going to write the distance formula, get the distance from that point to the focal point. So if you remember the distance formula, it's the square root of difference in my x coordinates, so x minus 4 quantity squared, plus the difference in the y coordinates. Looks like that's going to be y minus 3 quantity squared. So there's the distance from the coordinate xy to the focal point. Now I'm going to write the equation for the distance from my point xy to the directrix. Right there. So the coordinates of that directrix point or intersection point there, if I consider my x coordinate, it's going to be the same x coordinate as I have as my point, so x, and then from the x-axis I would go up 5 units. So that distance I'm calculating is from the xy point to x comma 5. So that distance, difference in x's, would be x minus itself, quantity squared, plus y minus 5, quantity squared. All right, I'm going to go ahead and simplify these, and then I'm going to square both sides. This first blue side of my equation, nothing to simplify, so I'm going to end up with the same thing. X minus 4 quantity squared plus y minus 3 quantity squared. On the right-hand side, what I wrote in green, the x's will cancel each other out, and all we will have left is y minus 5 quantity squared. We're going to go ahead and square both sides of our equation. Get rid of our radicals. X minus 4 squared plus y minus 3 squared equals y minus 5 squared. Now I want to go ahead and multiply those binomials. X squared minus 8x plus 16 plus y squared minus 6y plus 9 equals y squared minus 10y plus 25. And then I want to combine my like terms. I can see I have y squareds on both sides. Those will cancel each other out. I have y terms minus 6y and minus 10y. I think I'll move the 6y over to the right-hand side. So I'm going to add 6y to both sides. And then since I just want y's on one side, it looks like I'm going to have them only on the right side. I'm going to go ahead and subtract 25 from both sides. So minus 25 cancels that. And I'm going to do a minus 25 on this side. Let's scroll down, give ourselves some space. And I have on the left side x squared minus 8x plus 16 minus 25 here gives me a minus 9, but then I have this plus 9 here, so those are all going to cancel out. Now I just have the x squared minus 8x equals negative 10y plus 6y would be a negative 4y. So to get y by itself, I'm going to divide everything by a negative 4. And my equation is going to become negative 1 over 4x squared minus 8x divided by that negative 4 is going to turn into a plus 2x equals negative 4y divided by negative 4y is y. So this is the equation that I get, and that is the same as this one given to us at the beginning. So we showed that this point xy does have this equation, y equals negative 1/4 x squared plus 2x. Let's move on now to number 2. Similar kind of problem. We have xy coordinates. We want to show that the equation we get when the focal point is 2, 0, and the directrix is a line y equals, sorry, that's on the next line. I'm going to write it up here. Here's the directrix, y equals negative 4. This equation that we want to compare to, not in standard form, in vertex form. This becomes a lot simpler than using the distance formula if I know that formula that uses vertex form and that leading coefficient equivalent to 1 over 4p. This is the equation I'm talking about. In vertex form, parabola would have the equation that looks like this. And we want to know that our leading coefficient would be a positive 1 over 4p if I'm opening upwards, negative 1 over 4p if we're opening downwards. So I want to get a sketch of what this thing looks like. So I'm going to sketch my focal point at 2, 0. So let's see. 2, 0 gives me a focal point here. And the directrix is the line y equals negative 4. So I'm going to come down on the y-axis 4 units There's the directrix, y equals -4. And the vertex is going to be right in between this focal point and the directrix. So the distance between these 2 points looks like it's 4 total. Halfway would be here at a -2. So my vertex here, actually I'll write it on the right-hand side of the sketch. Vertex looks like it's going to have the points 2 over to the right on the x-axis, 2 down, or -2 on the y-axis. This helps me out quite a bit because the vertex gives me my h and k values. So I know now that h is equal to 2, k is equal to -2. And the only other thing I need to fill in my vertex formula here is the p-value. Now, if you remember, p is the distance from the focus to the vertex. So I need this distance here, which should be the exact same distance from the focus to the directrix. So p looks like it's going to be 2 units from the vertex to the focal point. And I want to see which way my parabola is going to open up. Here's the vertex. I have to kind of curve around my focal point up there, away from the directrix. So I'm opening upwards, so I know that my leading coefficient, 1 over 4p, is positive. Now I can just substitute in my values for hkp into my equation, and I will do that as y equals 1 over 4. P is 2, so I'm going to multiply that p by 2 and have x minus h. H is 2, quantity squared, plus k. K is a -2. I'm going to clean this up a little bit. 1 over 4 times 2 is 1 over 8. X minus 2, quantity squared, minus 2. And that is in vertex form, the equation that I get, which does match the one given to us in the beginning of the problem here. All right, let's go ahead and move on to number 3. If you feel like you're proficient at this now, you should be trying 3 on your own. Turn the video off or maybe pause it, see if you can do this on your own. We are going to find the equation set of points. That means probably a parabola, set of points equidistant from the point 0, 2. There's our focus. And equidistant to the x-axis, which is our directrix, which has the equation y equals 0. All right, I'm going to use the vertex form of the equation since this problem didn't say which form they wanted the answer, standard form, vertex form, or any other form. So easiest thing for me to do, use that formula y. Let's move that back up there. Y equals 1 over 4p. Positive if I know I'm opening upwards, negative if opening downwards. There's the rest of the formula. I need to sketch this thing to see which way we're opening. So, focus point at 0, 2. 0, 1, 2, here's the focus point. Directrix is the x-axis, so don't have to draw another line. This is my directrix. And my vertex then, going to be right in between this line and that focal point. So right here, vertex will have the coordinates 0, 1. That means that I know that h is equal to 0, k is equal to 1. My parabola is going to curl around that focal point. So it looks like we're opening upwards. And my leading coefficient then, which is 1 over 4p, must be positive. All I need now is that value of p, the distance from focus to vertex. That's a distance of 1 unit, so now I've got everything I need to write my equation. Y equals 1 over 4 times my p-value 1. Make sure this is a positive leading coefficient. X minus my h value is 0, quantity squared, plus my k value is 1. And x minus 0, we can clean that up. That's just x squared. And 1 over 4p is 1 over 4. So y equals 1 over 4x squared plus 1. And that's done. All right, if you're still watching, maybe you want to try the next one by yourself. We're on to number 4 on the back. We're finding the equation for the point's equidistance from the point 4, negative 2. There's my focal point, and this line y equals 4. There's the directrix. Problem doesn't say that this has to be in any particular form, so I'm going to just choose what's easiest for me. That's vertex form. As long as I know y will equal 1 over 4p x minus h quantity squared plus k. Okay, let's plot these points in directrix. 4, negative 2 is the focal point. Directrix at y equals positive 4. 1, 2, 3, 4. So here's our directrix, y equals 4. I need to find the point right in between this focal point, which is down 2 from the x-axis, and this point on the directrix directly above it, positive 4 from the x-axis. Total distance from the directrix at y equals 4 to the focus, 4 plus another 2, total distance is 6 units. So halfway would be 3 units. If I, from my focal point, go up 3, 1, 2, 3, or if I go down from the directrix 3, 1, 2, 3, I should get the same point here. There's the vertex at coordinates 4, up 1, which means that h equals 4, k equals 1. I'm going to have a parabola that is going to curl around the focus. Looks like this one opens downwards. So my leading coefficient, 1 over 4p, it's got to be a negative. We are opening downwards on the parabola. So when I figure out 1 over 4p, I want to make sure I make it negative. Okay, we need to figure out that p value. So I want the distance from the focal point to the vertex, and that's going to be 3 units. P equals 3. So my equation, I'm going to start writing this. Y equals negative 1 over 4p, x minus an h value of 4, quantity squared, plus a k value of 1, cleaning that up. Y equals negative 1 over 12, x minus 4 squared plus 1. And that's number 4 completed. All right, 5 and 6 you're going to find are a little bit different. When we sketch this, you'll see that we're going to have a vertical line for a directrix, which is going to mean our parabola is going to open up sideways. So taking a read on this thing, we've got all the points equidistant from a focal point at 4, 0, and our directrix is the y-axis, a vertical line. So when I sketch this, my y-axis is the directrix, and that has the equation x equals 0. And my x-axis, I need to find the point 4, 0. There's the focal point. Right in between there is going to be the vertex. So right in between this vertical line that's at x equals 0 and 4, 0, my point in between is this point 2. My vertex is at 2, 0. And the parabola is going to be opening up around the focal point. Opens to the right. So, a couple things we need to remember when we have a parabola opening up sideways. If this parabola opens to the right, then the equation that I want to use is switching my x's and y's with a positive leading coefficient. So I'm going to write over here, opens to the right, 1 over 4p is positive. And I switch my x and y values. And I switch my h and k values. So this formula becomes y minus k quantity squared plus h. For this problem, we know the vertex is at 2, 0. So that means h is 2, k equals 0. My p distance from the focus to the vertex, 2 units. So p is equal to 2. I'm going to go ahead and write this equation. X equals 1 over 4 times the value of p, which is 2. Y minus a k value 0, quantity squared, plus h plus 2, cleaning this up. I get 1 over 8 y squared plus 2. Okay, if you think you've got that one, try the next one on your own. It's the last one. And again, we're going to have a directrix, which is a vertical line. And it looks like we want to be equidistant from the origin. So there's our focus with coordinates 0, 0. Sketching this out. Want to see which way we're opening up. Here's the focus at 0, 0. And the directrix is the line x equals negative 2. So where x is negative 2, I have the directrix. So a point right in between those looks like it's going to be at the coordinates negative 1, 0. There's the vertex, which means h equals negative 1, k equals 0. And from the vertex, this parabola is going to curl around the focal point. Right here. And that means that we're opening up to the right, so opening to the right, 1 over 4p is positive. I need that value of p, which is the distance from vertex to the focal point, or the vertex to the directrix. That looks to be 1 unit. So I'm all set now. Everything we need to write the equation. X equals positive 1 over 4p y minus k quantity squared plus h. X equals 1 over 4 times my p value of 1. Y minus a k value of 0 squared. Plus an h value of negative 1 becomes just minus 1. Cleaning this up, we have x equals 1 over 4 y squared minus 1, and we're done. Hope that helps you. Have a good evening, everybody. Bye-bye.